I'm pretty sure the intro. Good evening, everyone. Um, Today, Dr. HN National College of Engineering's Alumni Association, we are throwing the third alumni lecture series. I'd like to extend my warmest welcome to our speaker of the day, Mr. A.C. Muralidhara, sir, and the deans, HODs, principal, and my dear friends. Today, we have our distinguished professional, Mr. A.C. Muralidhara, sir, who will be talking about interesting careers in oil and gas industry. I request Dr. K.N.B. Murthy, sir, our chief advisor, and Dr. Jayadevappa, sir, principal, to do the felicitation of the guest. It's a pleasure to have you here, sir. My friend Kruti. Yes, yes. My friend Krutika will be introducing the speaker for the day. Over to you, Krutika.
AC Muralidhara sir is a retired senior network communication specialist with over 2 decades of expertise in designing, implementing and maintaining mission critical communication systems for oil and gas industry. A student of the National Middle High and College 1974 to 1982, he completed first year BSc before earning his Bachelor of Engineering in Mechanical from UECE Bengaluru in 1987 and a Masters from Howard University. During graduate studies, he deepened his knowledge in data communications and programming while supporting a university computer lab. His career highlights include commissioning integrated systems for offshore oil production platforms in the Gulf of Mexico at HES Corporation from 2012 to 2016, single-handedly managing all communications for a major Caribbean refinery in St. Croix from 2003 to 2012 and supporting high availability networks on an energy trading flow from 1996 to 2003. Earlier roles included land engineering at the National Library of Medicine and network administration at Columbus School of Law. After retiring, he consulted for Caribbean refinery and storage facilities until 2022. Now, he pursues his interest in Jyoti Shastra, Veda chanting, and travels. Let's give a big round of applause as we warmly welcome Muralidhara sir. Over to you, sir.
ನನ್ನ ಬ್ಯಾಗ್ ಎಲ್ಲಿಟ್ರಪ್ಪ ಬ್ಯಾಗ್ ಮೇಲೆ ಕನ್ನಡಕ Thank you for the introduction. Um, Respected staff members and students of National Engineering College, welcome to you all. Hope you will find it interesting. First, I want to talk about just give you an overview of what oil and gas entails. So when you think about oil and gas, you are probably only aware that where to go to get petrol. That's the oil and gas is equivalent to petrol for us, or a cylinder for us. But how do you know where you get that oil from? So I just want you to understand the life cycle. So how many of you have bought rice? So where do you think, how do you get the rice? Everybody knows how to get the rice. So you go to grocery stores and you buy rice. And if you want oil and gas, petrol, you just go to petrol bunk and get the petrol. However, do you know where the rice comes from? What is the origin? What all it goes through? So how difficult it is, how much effort people put to get you from the ground up to the market. How many people work so hard? Similarly, in oil and gas industry also, there is a lot of effort that people put behind, all the different stages. So, why is that faded? Is anything? ಇಲ್ಲಿ ಸರಿ ಬರ್ತಾ ಇದೆ ಅಷ್ಟೇ ಪರವಾಗಿಲ್ಲ ಅದು ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಬೋದಾ ಇಲ್ಲ ಓಪನ್ ಆಗ್ತದೆ ಓಪನ್ ಆಗುತ್ತೆ ಬಿಡಿ ಅದು. That's the one. ಅದು ಕ್ಲೋಸ್ ಮಾಡಿ ಜಸ್ಟ್ ಕ್ಲೋಸ್ ದಿಸ್ ಕ್ಲೋಸ್ ಮಾಡಿ ಅದು ಬೇರೆ ಪವರ್ ಪಾಯಿಂಟಾ ಸೊ oil and gas, actually, it can be, it is actually divided into three streams. So one is called upstream, midstream, and downstream. So what we see is only downstream. So the petrol bunk and the cylinder that comes to our house, it's all downstream. However, like I said, the origin, where we get this, how does it come to downstream? So, as the name suggests, upstream is the upstream is the process or the stream where oil is extracted. So before we extract the oil, there will be some analysis by the geologists, chemical engineers, and various other scientists. They will determine this place is ideal for drilling. So, for example, now we know Indian government just announced that we have found oil in Andaman and Nicobar, near the Andaman Nicobar Islands. So we have reserves there. But we know that there is reserve. But now the next process, how does it, come up? So when they determine that an area is suitable for extracting the oil, they do the drilling. So they drill the wells. Actually, the process is called drilling and completion. So they drill until they get to the source, the crude oil source, and then they actually there's a process called completion. They do use blowout prevention valve, BPV. So have you seen, anybody seen a movie, Hollywood movie called as The Deep Horizon? Has anybody seen Deep Horizon? It's a movie based on a real story of BP, the British Petroleum Company. It actually stuck there. It is stuck, huh? I don't know if it is my computer or is this thing. Slide 2, okay. Okay, now I got it. Don't worry. Yeah. So, like I mentioned, upstream, midstream, and downstream. So here is where you see an oil platform here, but this is actually after drilling and completion. So they determine the area where the oil deposit is available, and then they do the drilling, and they do okay. So this is something, a process diagram here. So a ship is drilling, and this is an oil well, and this red thing is blowout prevention valve. So this is very important, because when they go deeper and deeper, there is higher pressure. So it can explode or leak oil from there. So this valve is important. Okay. All right, thank you. So for drilling, there are, I'll go through that. So in the sea, when the shallow water, that is not so deep here, for shallow water drilling, they call it, called as jack-up rig. For a little bit deeper, from 2,000 feet to 3,000 feet deep, they use this semi-submersible. And for deeper sea levels, they use these drilling ships. So this is how it looks like if you are looking from the front. So when they drill the hole, they do all these various pipes in here, and they do cementing, and a lot of process is involved there. So let's say after that, the oil starts coming up. They will produce the oil. They will pump out the oil, and the oil needs to be transported to a refinery. So the midstream is called storage and facility. That is the function of the midstream. So the storage is in the large steel tanks, or probably in Andaman near the Andaman region, they will use what is called as FPSO, which is a floating production system offloading, which will be there will be a ship next to the platform where the oil is pumped first to the ship, and the ship will bring it to the refinery or to the storage unit, and from there it goes to the refinery. Or most of the time, the refineries are actually in the shore, so they will be constructed in the shore. For example, Reliance refinery is in Jamnagar, which is very close to the port. Large vessels like super tankers, which have capacity between 1 and 1.5 million barrels. Now they have mega ships which can carry 5 million barrels, and they don't come to the shore. They will have a small mini island off of the facility, and they will offload right there. It's a single point mooring, that's what they call it. So mooring is almost like a small island. So midstream involves storage and transportation. So in the United States, we have pipelines going across the US. Even now in our state, we have pipeline coming from Mangalore to Sundura, that is near Nelamangala. So before trucks would carry crude oil from the port of Mangalore, from the refinery, the finished products, I would say, finished products from the Mangalore refinery, and they would bring it in the truck all the way in that Ghat section. But now, refined oil is pumped through the pipeline, which comes to Nelamangala area. And actually, Nelamangala to Bangalore airport, they have a pipeline. So when the Bangalore airport was constructed, we had storage facilities near the airport where trucks would come in every day. A few loads of trucks would come in and store in the oil in that storage tank. So anyway, and then the downstream is where the marketing, refinery is also downstream basically. Refining and marketing is called downstream. And marketing, happens in the retail, in the gas stations, and sometimes we don't trade oil contracts here in India. I don't think so, but in New York there's an exchange dedicated for commodities. It was New York Mercantile Exchange, where oil and gas was traded several months future, 36 months future actually. So this is basic overview of the function of oil and gas industry. And from the refinery, there are when in the refinery, when the crude oil is refined, you get various products. I think this engineering college does not have chemical engineering as a subject, so I will not go over the details. Basically, you have only IT, computer science related courses, I think. Electronics and communications also, okay. So I can talk about communications. Okay. The gas cylinders, the same thing, it comes. So this is onshore production area. So, this this is horse jack, they call, and it pumps out the oil continuously. So the oil from here usually is transported in the pipeline to the next uh, facility where it actually gets stored. This is a typical picture of a midstream. So you can see so many pipes and compressors along the way. All these valves are controlled to increase the pressure, so they can actually transfer crude oil from one place to another, are also finished products. So basically, this is another schematic sketch. So oil and gas is pumped out. It goes through a separator process. Oil is transported separately. Gas is transferred separately. Oil goes to the refineries. And from the refineries, they go to storage. There is another point here. So from storage, it goes to gas stations or petrol bunks, number 6 oil, number 3 oil, and so on. And in the top, so this actually is a unit called as coker unit. So the coker unit is used when there is heavy crude. There are 2 types of crude oils. So heavy crude and the light sweet, they call. So the light sweet is easier to refine. That's what we have in Gulf of Mexico, Gulf countries, Saudi Arabia, Qatar, and all those places. So those are light sweet crude. And the crude oil in Venezuela and West Texas and some other areas, they are heavy crude. So heavy crudes, it takes extra process to refine. And the byproduct there, you will get coke. Coke is like a brittle carbon material. It has its own uses in pharmaceutical industry and water purification and so on. This is the refinery that I worked. It's in the Caribbean. Actually, this is also from the same refinery. So, as you can see, there are so many tanks here. Each is capable of storing 2 million barrels or more, actually, of any oil, actually. So there are storage tanks for various gas, like byproducts, like benzene and butane and propane and things like that. They are stored in this area. And as you can see here, there are 1, 2, 3, 4, 5, 6, 7 ships docked there. And this is a very condensed picture, because this itself is about 150 to 200 meters, this whole ship. So as you can see, from this, where the refinery road is, from here to here, it's 3 kilometers from here. It's about 2 kilometers to here. So, and this is about another kilometer. So 3 kilometers from here to here. And then from here to here, it's about the same or a little bit more. So this total area is actually 4,000 acres. This whole area, this is a residential area, quarters here, and then this is quarters here, and then there's some empty space here. This used to be the second largest refinery in the first largest hemisphere, largest refinery in the Western Hemisphere, and it was the second of the largest in the world. And this is a typical trading floor. So let me show you some pictures. Okay. ಹೇಗದು ಬರ್ತಾ ಇದಿದ್ರೆ ಸಾಕು ಅವಾಗ ಡೂಪ್ಲಿಕೇಟ್ ಮಾಡಿದ್ರೆ ಆಗಿರೋದು ಹಾಂ ಗೊತ್ತಾಯ್ತು. So this is a production platform. It is actually sitting, this crawley is like a barge actually. So this production platform is being carried from the shipyard to its final destination. So this is, if you ask me, okay, this is just a production platform, what do we have to do with this? We are IT, we are computer science. We have nothing to do with this. You're totally wrong. So this is a mini office with 150 people living in this. This is a living space, living quarters and offices in this area. So about 150 people work in this office, and they need computer. They need access to their files, their network, corporate network. They need access to the internet, and they all have a phone, and they need to have an inbound telephone and outbound telephone. So, and then they need Wi-Fi connection, wireless connection for their laptops or for their phones, and to get to the internet. And then there are some guests that come on the platform. They need guest Wi-Fi access. And there are so many other things. There is radio communication happening from one area of the platform to another area. So actually, I will show you the final place for this, where this platform is going. So if you look at it, this is called hull. So this is a floating production platform. So, all these chains anchor this hull to the seabed. And this actually floats, but it doesn't float away. It floats like figure eight, but it doesn't float away. So the previous slide, this whole platform is lifted by this gigantic, monstrous crane, and it is placed on this hull carefully, and it is leveled, and they do adjust the height, which is called as ballasting, by adjusting the chemicals in it. So it actually, from sea level to here, it's about 100 feet, 85 to 100 feet. And if you see these antennas here, the antennas are about 190 feet from the sea level. So, like I said, the function of IT in these platforms is to establish communication to the home office and to provide all the IT services on the platform. And this structure here is made out of steel. It is blast resistant trailer, basically. So the radio communication will not happen inside. It will not penetrate this building. So how do the people inside communicate? How do they know what radio call is coming? And there are several key important communications that need to happen. You are expecting a helicopter to land here. The helicopter tunes into a frequency where they own they pay for a frequency. They own a frequency, radio frequency, and helicopter tunes to that frequency and announces we are 20 minutes away, and that signal should go to the control room inside this steel bunker. So they install gateway from radio signal to IP signal. And in the control room, there is a radio over IP set. Motorola makes it. And you program it to certain frequencies, and it will receive the signal. Actually, it is not frequency, sorry, it is a multicast address. So I think everybody is in second year or third year. No final year student here yet. First and second, okay. So I don't know if you know the difference between broadcast and multicast. You're not familiar with multicasting. So broadcast is something that if you send if something comes to a switch, it will go to all switch ports. Everybody that is connected to that switch will get that signal, right? Broadcast is like, hey, announcement, like, hey, who has this IP address? I need to transfer. Who has this MAC address? I need to send something to the device, and so on. So it's like a broadcast. Whereas multicast is something that is based on subscription. If a device is connected to a network port, only that port will subscribe to that signal. Everybody else in that switch will not get that. So which is actually good, because it is not bombarding with data to all the devices. If it broadcasts everything, then all the devices will work really, really slow. It will make it slow communication. That's not efficient. So basically, when you come to multicast, or when you study that, you will understand better. But what I was saying is, so only the radio over IP will get that multicast address, and then they will receive the signal from the helicopter, and they will be ready. So if you look at this, there is a crane here on the platform. So they will, which is close to the helicopter. So the crane will all, stop operating. All the work on this floor will be stopped. And they also announce when they are 5 minutes away. So all those things, are important for IT, for communications people. And also the vessels around the platform, they use a marine radio. So the marine radio they also need to communicate with the control room. So they will be talking on a marine band radio, and the same gateway will convert the marine radio signal into IP signal, and it will be heard in the control room. So there are different functions that go on here in this platform. There is power generation, you need a AC, and all the things necessary for living for 150 people. And also you need power for all these processing units. So 24/7 it has to be available. So all the functions are happening in these areas. And there is in here there is a control room. This is a process control area. So where the production volume, um, uh, input and output of all the crude oil from the ground to a pipeline. There is a pipeline nearby, so when this constantly pumps up, and then the oil needs to go to the pipeline. It will be going to the pipelines. So there are various functions here, the instrumentation that will measure the inflow, outflow of the crude oil. And there is a flare. If there is any excess oil that increases the pressure or something, it will if it causes the damage to any other equipment on the platform, they will just burn it off. The oil is burnt off in that flare. Let's see. And if you are an IT person, you have to go there and set up all these things. During commissioning, you are the first one of the first few people that will be called in to go and set up everything. Commissioning is a long process. You have to make sure that every feature and functionality is working and signed off by the people that operate this platform. And you may have heard the ship being commissioned. Commissioning of a ship actually takes several months, actually. So that is upstream business. So this is all, this is when the platform is new, people cannot stay overnight on this, in this facility. Nobody can sleep. So during commissioning stage in the beginning, people stay in this ship here. It is a floating motel, or you can call it as flotel. And you transfer to the platform in the morning, early morning, like 5:30, and the work starts at 6 o'clock. It is a 12-hour shift. At 6 o'clock, if at 5:30 in the evening, you line up and you come back. So the process of, let me see. Let's see. Video. What happened to the video? ಇಲ್ಲ ಸೌಂಡ್ ಇಲ್ಲ. So, do you have any questions for me until now? Has anybody understood anything so far? I was also like you when I was in second year. I didn't understand anything. I was just...
Do you have any questions?
taking up time. It's taking up time. Opening is opening. Bartade. Edited video no okay, this is game. Okay. See, as you can see, the waves are, high. We are in the middle of the ocean, right? The boat is actually going up and down. And people that stayed on that boat, now they are being transferred. There are like 7 or 8 people around here. They are being transferred from the boat to the platform. So, for your information, I have done that. As an IT person, you may be doing that too, if you join oil and gas. Okay. You are going all the way about 300 feet above the sea water, sorry. This is called basket transfer. And this is not the usual way. There's another usual way that people do come on the platform. This is only during the commissioning of the platform. It is not when the platform is running. Windows Media Barlilla. Let me close that. Oh, okay, here it is. Okay, usually this is the normal way. People line up to come on the platform. So they're all lined up. So 5:30 in the morning after breakfast, they just assemble. This is only a few people. Up to 100 people come later. So this is a bridge that is on the ship here. So, and you can see the ship is, going through the motion, and there is a gyroscopic, like telescopic legs here that actually keeps this level horizontal at all times. So this portion comes and attaches to the platform here, and then there is a signal light here. When it turns green, the other person walks from the other side, one after another. So for safety, everybody must wear life vest to cross over from the ship to the platform. And it usually takes about 20 to 30 minutes to transfer everybody, like all the 100 people. Okay. So this is another gas plant in West Texas, where I had to set up communications from one building to another building. The two buildings are about 10 miles away, and there is a new tower on one side, and there is an existing 25 feet tower on the other side. One on this side was 100 feet tower. The way you have to, it's a 1 gigabyte air fiber. I had to establish the communication between the two sites. The climber goes up with the equipment, mounts it, and on the other side, the same climber goes up. But I had to communicate with the person on my side on a radio, and the other side, my partner, he's actually on the radio with the guy who went on top of the tower on the other side. But my friend and I, my partner and I, we are actually on the phone call. So we aim approximately, and then the fine tuning, I had to tell the tower guy on my side, because I was connected to the computer and I was watching the signal levels and things like that. So I had to tell him, okay, you just, you go left, go right, okay, come back, and that's the right spot. And that's where you get the maximum. We could get 865 Mbps speed for a gigabit fiber, air fiber, sorry, gigabit air fiber. And sometimes I had to go on a bucket truck to establish some temporary connections. So this is a drilling ship that was fabricated in Hyundai Heavy Industries in South Korea, in Busan, South Korea. And that's where the meeting is happening between Chinese premier and US president right now, Busan. So anyway, that is the world's largest shipyard, Hyundai Heavy HHI. And this ship was fabricated there, it was built there. And I had to go on this ship to establish communications, to set up communication from here to our home office. And the ship had satellite connection. It was working in one band until Cape Town, and then it had to switch band when it came to Canary Islands. Canary Islands are on the west coast of Africa. The islands belong to Spain, and it is very famous for ship activities. So this ship was supposed to, it went there, and it was fitted with some other modules on the ship, and it had to come to Gulf of Mexico for drilling. One other thing, for the drilling operations, when Deep Horizon accident occurred, there was a oil leak in Gulf of Mexico. To prevent that, the government came with a strict rule saying that all the activities for drilling had to be monitored by a drilling expert, drilling engineer expert, in the home office 24/7. So all the data that is collected, when the drilling happens, there are so much of information that gets collected, and it has to be sent back to the home office. That's another communication requirement. In real time, whatever is happening in the drilling has to be monitored from the home office. And for this, it's the only available communication is through the satellite. And for the platform, there's other ways. I forgot to tell you guys. So anyway, when drilling, the ship has to maintain its position. So it is built with some, gyroscopic motors that actually maintain the position of, the geocentric position while drilling. And they insert drilling like tubes, which is 20 feet standard, I think. And then they actually, once they insert in the casing, they do some cementing and all the work so that the tubing stays in place. So this is another drilling ship that I worked on when it was on the dry dock in Bahamas. A typical, closet or a rack in the shipping, in the drilling ship looks like that. This is satellite controllers, and then they have a breakdown switch here, and then we actually take one connection from here to our equipment here. If you can see here, this is HNNCE. This is our company, and there are other companies on the ship in fact, the drilling company itself will have their network presence there. This is another port where all the materials are transported. In India, the drilling area, all the drilling is controlled by the government, whereas in the US, it is all privatized or it's contracted out. And these areas, there are designated areas, and then each company, wins in a particular area in auction. So for example, one of the platforms that I designed is in Mississippi Canyon, and these are all numbered blocks there. MC 724 was our platform. That's where, in that block, our platform was there. There is huge activity in this Gulf of Mexico, which is, extracting so much oil. The platform that I worked on in Mississippi Canyon was about 80,000 barrels per day capacity. So it would pump out 80,000 barrels per day. So each barrel, let me just give you an idea. Each barrel, you can probably see, you have seen barrel. Barrel is 40 gallons. 1 gallon is about 3.78 liters. So each barrel is 40 times 3.78 liters. That's how much crude oil it pumps out, 80,000 of those barrels in a day. And there is another platform that where is that? This platform is about 120,000 barrels per day. And there is a difference between this platform and the one in the previous one. This is called as tension leg platform, TLP. In fact, these four legs have an extension all the way to the sea bed. The depth of the ocean here is about 3,800 feet. So this is standing, this column only goes about 20-30 feet, but rest is all, it's almost like a basement, it just goes all the way, extends to the seabed. And this is a production platform where about 130 people live. So this is where, the living quarters for this platform is, and there is a helipad. So once you set up everything, you only go there occasionally as an IT person. So on the platform itself, you have several processes happening. So you have to extract, and they collect all the data points. So the pressure, temperature, flow, various other parameters that go into SCADA network. And then the SCADA network is a control network. It actually, it has to be highly, highly secure, because if I, as an IT person, if the data is compromised, if the security is compromised, if somebody can reach that production platform network, they can sabotage the platform. They can actually, the enemy can blow away the platform. So as an IT person, you have to, take care of all the function. So duties here in the jobs that, some of the jobs, that functions that you can do in these platforms. You need to make sure that the data availability and the distribution of the data, you know, and then you have to make sure that the data is available only to authorized people. So the data security within the local area network, right? And data access control, that is. And internal and external, the cyber security. So you have to protect the enterprise from the internet, and then you have to protect this control network even from the corporate network. The corporate network should not be allowed to communicate with the process control domain. There is a security model which is, you will probably learn that. It actually has two firewalls. This production control network on these platforms will go through two sets of firewalls. One set on the corporate side and another set towards the process control domain. So since you guys are only in first year and second year, you probably haven't come across anything in the network security or anything like that. So let me try to stop here and see if you guys have any question. Do you have any questions, anybody?
We have 20% of ethanol which enhances the petroleum product. So is there any chemical so that the petroleum, whatever we get, the crude oil quantity can be reduced, and we can use the artificially synthesized like ethanol or any chemicals which can be added so that it enhances the performance of the vehicle?
Well, that is what ethanol does, right? In here, okay, in the refinery, okay, there is a process called as gas blending, and they actually the function of that is just what you just asked, okay? So you get 92 octane petrol, you get 94 octane petrol, and you get 88 octane petrol. So all these are controlled, it is made 92 octane by adding certain chemicals or the proportion in a different proportions. I'm not a chemical engineer, for your information. I'm an IT person. So, but I know there is a process called gas blending, and that is where the the volumes or the quality of the petrol is adjusted. Okay. Yeah.
Sir, one more thing is, in the midstream operations, is there any process for the automation there?
Yeah, most of it is automated. Every process is automated. Actually, that's again, I didn't want to talk about much. SCADA is there in every function, except trading. So in midstream, in the storage, as well as in the pumping, the whole thing is automated. So there is, like SCADA system, of course, data acquisition and control. They do automatically adjust some compressors, may get turned off or some turned on based on the distance the oil needs to go, gas needs to go, and so on. So, and the same thing with the storage, in the I told you about the 2 million barrels per the storage facility. The cap is closed so that there is no evaporation. It's a collapsible top. So the oil from the ship actually is pumped. In a refinery, there is miles and miles of pipes. So the mechanical engineers actually are needed actually to design all those. There is a whole branch of called as pipe design. Okay, and then there is a inspection and so on. But what I'm saying is the oil from the shore is pumped. Let me just explain here. I had one of the pictures of the refinery, right? Okay. Yeah. So if an oil tanker comes here, right? So there is a dock attendant here, and he just connects the pipes or whatever. And then the whole thing is automated. There is a pipe here, and somewhere, first when it comes, it goes to quality control and see what the ship is bringing, how much water content or whatever, because that is very important. So it goes and starts filling up in this tank, for example, right? The first tank. So here there are redundant systems to make sure that it doesn't overflow or there is no leak. So there is a wire inside that goes up and tells you how much volume is being, what is the level and what is the safe turn-off point. And there is a control room that will be monitoring everything. And also there is another sensor on the top here, and it will send signal wirelessly that okay, this is the distance. So it cuts off automatically. When the thing is complete, it will switch over to the next one, or it will give you warning when it is 60% and so on. So most of this operation is automated, and it is all monitored, and and it's also stored in the database. So IT and software engineers basically write all these codes that the data structure they design, and then the GUI for all the operators to monitor. It's all set up, and it's all it color coded. Sometimes it's red, sometimes when the level alarm goes off, it will be cleared, or it will become yellow and things like that. So any other question?
So my question was, how is the supporting infrastructure created, like the 4 pillars?
How is the supporting infrastructure?
Like the 4 pillars are constructed in the middle of the sea.
In this drawing?
Yes.
So what exactly the question? How is
it constructed?
How is it constructed? Okay. This steel structure is all constructed in a shipyard. Okay. So basically this whole process from design to implementation takes about 2.5 years. Okay. So somebody comes up with the design, like they select whether it should be a tension leg platform or a production platform based on certain conditions of the sea also. Okay, if it is lesser depth, maybe they go for this and so on. And it is sitting, I was telling you, it is sitting on a, I have seen the process, so I will explain how it works. They have 1 meter wide pipe, which is about 50 feet or 100 feet long, right? So they have in the bottom, in the seabed, they actually construct what is called as pad. And humans cannot do that. Humans cannot go there. So it is all done through ROVs. So if you are good in video game, you can do some good job there actually. So it is all constructed, okay, and that tube, 1 meter width tube, 100 by 1 meter, it actually, there are 3 tubes side by side for each leg. So there are like 12 tubes running from the platform all the way to the seabed. So I've seen the storage where the the tubes were stored. I think for some of those tubes, they do fill with cement. But maybe the top ones may not be. I don't know. I'm not 100% sure. But when you're working on the platform, you can see the reason why they call tension leg is because there's a lot of pressure in the water, in the seawater. So it actually has to bear a lot of force. And there is, when the machine is running up and the pumps are running on the top here, you do see, hear some vibrations from here, from the base, basically. So this yellow column, it only goes about 20 feet, right? So the basement pipes, they're called tendons. That's what they're referred as, tendons. So the tendons, they come to that level. They stop about 30 feet below the sea level. And the divers go and actually they put these 4 legs on the 4 platforms and then they tie up. The process is called tying up. So I'm sure they put heavy bolts and things like that. So this cannot be adjusted. The heights, once they place it, the height of the platform will not be changed. It cannot be changed. Whereas the other one, floating production platform, you can actually do ballasting, and then you can adjust the height of the platform. So did I answer your question? Was it okay, satisfactory for you? Okay.
Good day, sir. My question is about how you deal with oil spills. Like we hear about oil spills during midstream, but I wanted to ask about oil spills during upstream. Like while they're drilling, do oil spills happen? And if they do, how do they deal with that?
It really, you don't have a room for leak in upstream. The only major incident that happened was it was a real story that was made into a movie, Deep Horizon. In that spill, what happened was the pressure was too much and the blowout prevention valve could not handle it. And it was actually, they were supposed to put it, or maybe they didn't put it in time or something, but the pressure was too much. Somebody may have made some wrong decisions, or maybe they were, they didn't take action in time. But most of the time, the spills don't happen. And the Gulf of Mexico oil leak was a very, very major one. It actually affected so many people along the coastal line. The fishermen could not do fishing for months and maybe for years. So they were getting compensated from BP. It's a huge, and they had to clean up. The way they clean up, some of it, they pump it out. Some they use what is called as booms. They are the absorbers. So they absorb oil and water. And, but booms work only for a small spill. For the large spill like that, you cannot really control. Maybe they pump out to the ships and took it out. But as you know, oil is light, so it will spread. So in the dock area, if there is any spill during transferring, that's how they control with the booms. So which is like absorbers, like, so they like cotton, basically. So they actually absorb the oil so that there is no spill. I'm a IT guy too, so you're asking me all kinds of process questions, chemical questions. So it's okay. That's okay. I worked in the industry for some time, so it's okay. I can answer. Any other question? That's a political question out of my scope. Sorry.
Sir, my question is EV is going to replace petroleum vehicles in upcoming years?
EVs?
Is going to replace petroleum vehicles in upcoming years?
To some extent, yes, but not 100%. No. Because you see, oil is used in many other applications. See, you have to understand what is the problem if you use oil, right? So, yeah, environment, ozone is burning, depleting, and so on, right? So for that, they actually think that the reason is because of the sulfur present in the in the petrol, right? So they reduce the sulfur quantity as much as possible. And do you know in the world how much diesel is used every day in maritime industry? There is shipping, there are thousands of ships all around in the world actually right now in waters going from some place to another place. So all of them are actually using oil. So luckily they mandated a couple of years ago that maritime industry actually came up with a rule saying that they will only use low sulfur diesel. So that has reduced emissions significantly. So sulfur is the problem in the petrol. So if they reduce the quantity, so maybe by using other additives like ethanol and so on, maybe it will still be used. EVs may not 100% replace, but to most extent, like maybe 80% of the vehicles may be EVs. Yeah. Somebody, when I was going to masters, many people discouraged me from not taking petroleum engineering as my master's course. However, when I started working for oil and gas, the engineers there was like, you're an engineer, you're a mechanical engineer, you should work as a petroleum engineer. But then it was too late. I was already into IT, many years into IT, so I didn't want to go back as a fresh petroleum engineer at that time.
Last question, anyone?
Sir, how is petroleum and diesel classified into different categories like 91 quality petrol, 90 quality petrols and all?
Yeah, that's based on the quality of what do you call the heat, calorific value, whatever that, it is entropy, right? You don't study entropy, right? What is the energy capacity of that product? How much energy it can generate. So what it has, right? So 92 is bad. 94 is better fuel than 92, and then the 88. It started. We used to use 88 before. I think now it is all 92 calories. 92 here octane, but in many, I don't know if it is here also. What is the value for octane value for speed petroleum? Do you know speed petrol? Speed petrol. They have two kinds, right? The petrol here. So one is better than the other one, right? That's what they say. So one has more heat value. It can produce more heat or more power than the other one. So it is all done in the gas blending process. So before you all go, I have some things to say to you, okay? Since you're all in second year, you're going to have 2 more years of college, right? And for any job, there are some essential qualities that you must possess, okay, to do a better job than the rest, than the others, okay? I want each and everybody to improve your physique. Hello, madam. I want each and everybody to improve your physique, physical strength, physical look, shape, okay? When you have good physique, you will have confidence in you. You will present yourself better, okay? So that is one first thing. And as engineers, as IT engineers, IT jobs are not the only jobs, okay? I want each and every one here, and your fellow students who are not here, you should tell them, they should consider a career in the Indian military services, okay? Short services commission for a shorter service, or you can become a permanent service member. As an engineer as an engineer entering into a military service, you will have a lot of opportunities. You will learn a lot of things in life. You will become real people, okay? And I want you to improve. Keep these things in mind. You will thank me when after you get into your job and several years after that, okay? So I want you to become good in communications. How can you become good in communications? First, you have to respect everybody. And you have to listen completely. The other person who is talking may know, or definitely will know, something that you don't know. However small that guy may be. Maybe you can become a manager and you're talking to a servant. That servant knows something that you don't know. Keep that in mind. So you have to respect everybody, okay? And then when you talk, you make eye contacts and talk clearly and confidently, okay? So these are some of the things that teachers don't tell you probably these days. You need to know, and you have to practice, you have to learn these things, right? And I want you to be punctual with time. On time, always be on time. Calculate, manage your time properly, okay? And always speak truth. Even when you made a mistake and somebody catches you doing the mistake, speak truth. Only the speak will prevail. Only the truth will prevail. Satyameva jayate. Right? Everybody makes mistakes, so you will be pardoned, even if you make mistake. But just don't make blunders. So do not expect anything more than what you have agreed to receive as your payment. Be honest. Be honest to yourself, right? Have an integrity. As a person, you build up your own integrity, okay? And learn to work as a team. This is a problem these days. Everybody works in their own terms, their own, pace. Be a team player. Talk to the people. You will learn from one another when you work as a team, okay? How many people know Samskrita? Acharyat padamadatte, padam shishya swamedeya, kalena padamadatte, padam sadbrahmacharibihi. Okay, So you only learn 25% of the knowledge. You only get 25% of the knowledge from the teachers. Another 25% you from your self-effort. You are going to learn from your own. Another quarter you will learn over a period of time. And then the last quarter is more important. It is the one that you learn from fellow team players. Okay? Never be arrogant. You may be a first rank student or you know a lot of things, right? When you go to work, treat that workplace as another school, higher level school, because you will be learning something new every day. Be willing to learn, be humble to learn. Don't be arrogant that, oh, I know, who is this person to tell me? I know already. No, don't have that attitude. So keep open mind and willingness to learn something. Always maintain work and personal life balance. Okay? Don't take work home, and then don't bring your personal problems, home problems to work. So anyway, you will thank me when you realize all those things. So if you have any more questions, let me know. Okay, there is another gentleman. I know you are getting late. Some people.
Sir, my question is as to what role does digitalization play in modern oil and gas production?
I'm sorry, speak a little bit slow.
Sir, what role does digitalization play in modern oil and gas productions? My question.
Most of the stuff is already digitized. You know, analog signals, very rare, except the, like, the walkie-talkies and things like that. As far as I can see, most of the stuff is digital. Analog, some of the things are there, but old system, it's all, even the process control, everything is digitized now. It's not, there is no analog, it's at least a few of you get interested in oil and gas career, which is, I feel that it is very adventurous. You fly in the helicopter onto the platform and you go there and you climb up 300 feet towers and you actually do the inspection, install Wi-Fi bridges and so on. For me, it was a very interesting thing, and always be willing to accept challenges. The challenges are the ones that make jobs interesting. All the best to all. Okay, thank you very much.
Good afternoon, everyone. It's my privilege and pleasure to present the vote of thanks on behalf of Dr. HNNCE for today's inspiring seminar organized by Alumni Association. I would like to express our heartfelt gratitude to our distinguished alumni, AC Muralidhara sir, who took the time to be with us and share their invaluable insights, experience and guidance. Thank you so much, sir. Your words were truly informative, sir. And I thank everyone here who made this event a grand success. Thank you. The refreshments are available outside, so